This project is all about spotted wing Drosophila, which I hope that most of you have heard of already. And this is a multi-industry funded project, which we are very excited about. So it's not only Hortgrow that's funding this project, it's also the South African table grape industry, the South Africa wine, as well as Berry ZA. And this project actually is divided into sort of two large aims, and we're funding 4 MEC students in this project. So Drosophila suzuki, or spotted wing Drosophila, targets healthy ripening soft-skinned fruits, including several stone fruit and cherries. And the reason why we are interested in this Drosophila, unlike other members of its family, it actually is able to cause primary damage using a serrated ovipositor, which is similar to what we would see from what we refer to as true fruit flies, so flies like the Mediterranean fruit fly. And they can cause rapid spoilage, high economic losses, and of course risk to exports, although we know that spotted wing Drosophila is already present in many of our export markets. So losses of up to 80% in fruit yields have been reported in other parts of the world. This fly was first detected in South Africa in 2022 based on sort of low surveillance that was conducted by Hortgrow and some other industries where this fly was detected for the first time. So because it's a new invasion, we have very little information about spotted wing Drosophila and how it will react and interact under local conditions. So I hope you can see the dots on the map, but this is the most recent map. So the date there says 17 May 2025. So Hortgrow is still continuing their surveillance and the monitoring of this based across our production regions across the country. We're also assisted by some of the other industries as well as other bodies, for example, the ARC in Mpumalanga. So the red dots actually in this map indicates presence, so danger, and the green dots are where it's absent. So you'll notice from the map that spotted wing Drosophila is now present in all of our provinces. Basically everywhere that we've put a trap, we found it, except for the Northern Cape. That's the only area where we have to date not found it. So the overall aim of this project, as I mentioned, we have very little information for this space in South Africa, is to get a better understanding of the fly's bioecology in South Africa, and also to look at some options for management and control. So I've already mentioned that this overall aim is essentially divided into 2 big projects, and it's also subdivided into 7 more specific objectives. So the first 2 objectives on the screen there now is looking at attraction products or bait products, as well as some attract and kill technology. We know that fruit fly is also managed through these means quite successfully. So the first objective is to isolate and test the yeast Hanseospora ovarum for its attractiveness and compatibility with insecticides. This is something that's been shown quite potentially very important in other parts of the world. And in addition, also to test existing commercial attractants through field trials across South African soft fruit crops. The next 2 objectives got more to do with some of the risk. So here we're interested in assessing the susceptibility of different cultivars at different ripeness stages. And this will be done first in the laboratory and then also validated under semi-field conditions. Some work in other parts of the world have already shown that, especially in berry cultivars, there are differences in susceptibility between cultivars, and that will of course play a role in the risk that is perceived. So on the screen there I have a little bit of preliminary data that one of our students, Lisa Klein, has gathered. And what I would like you to note is on the y-axis, it says average number of spotted wing Drosophila per kilogram of fruit, and you'll see that the scale there goes up to 7,000. So this insect is quite prolific, and we find quite a lot of them if we allow them to breed in fruit. So essentially in this very preliminary experiment, what she did is she looked at ripe versus unripe blackberries, and she just looked at whether they like it or not, basically. So the first set there, the bars, the dark green bars are ripe fruit, and the light green bars are unripe fruit. And she has some measurements there in the table looking at pressures and at Brix values. So in the control, you'll see where the fruit was not exposed to the flies, we still found spotted wing Drosophila. So the reason for this, and obviously we didn't know this when we were collecting the fruit from the field, is that those fruit were actually already infested. So obviously those fruit were also exposed in the lab, and then we similarly did this work in the field. And those semi-field experiments, essentially, she enclosed the fruit with flies in the bag, similar to the work that Arcia presented. So in the lab experiments, you'll see that there's no difference between unripe and ripe fruit. It seems like if they under high pressure, they may not have a preference. But again, as I mentioned, the ripe fruit collected from the field most likely would already be infested. And you can see again that very strange, very unexpected result in the field exposure where the unripe fruit had such high numbers. And this is, of course, a very small pilot, so more work is on the way. So the fifth objective is looking at the evaluation of alternative methods. So we're looking at predators, parasitoids, and pathogens. This objective will look at surveys collecting some of these, hopefully, rather collecting some of these alternatives from the field, and then also screening some of these in the laboratory. And there will also be a focus on commercially available EPNs and EPFs. And then the last two objectives for these projects will look mostly at risk assessments. So one of these are looking at monitoring of seasonal patterns. We're not sure what this fly is going to do in our different production areas under different climatic conditions. We've already seen some very interesting results just based on the monitoring that we're doing, where it gets very warm, we have very low trap captures, and then now as the temperature cools, our trap catches are increasing quite a bit. So this objective will look at that seasonal pattern, and it will also look at alternative hosts, which we know they have many of, and potentially the importance of managing those in the agro-ecosystem. And then the final objective is essentially pulling together all of the information gathered throughout all of the different objectives to build a GIS-based risk assessment tool. So on the screen, you can see all the funders. I already mentioned this is a multi-industry project. You can also see an image of the students. So we have 4 MSc students, Andrea, Chloe, and Lisa, and then Heinrich there in the top left corner will join the team very soon. Thank you.